Have you ever wondered if machines could possess intelligence? If so, congratulations, you have asked a philosophical question. Have you ever asked a machine about its own intelligence? If yes, kudos to you. You've exhibited a behavior that is fundamentally human. In fact, since the dawn of time, humans have unsouled objects such as stones, trees, and automatons, treating them as if they were persons, not to mention their pets. This very human kind of behavior is called anthropomorphism. By the way, this is not to say that people engaging in anthropomorphic behavior throughout the ages have attributed theoretical and possibly non-existing entities called souls to these objects. Interpreting their behavior in these terms is typical of current theorizing in much cognitivist neurophilosophy, and not necessarily reflecting the beliefs held by these people themselves. But wait, I now hear you say I haven't asked just any machine if it is intelligent, I've asked a computer. I certainly wouldn't ask an old typewriter if it is intelligent. All right, great. We're in the midst of a fascinating philosophical discussion. As a matter of fact, this discussion has been going on for a long time. Let's give a brief glance at some select historical moments, starting with a classic definition of AI that has proven influential until today. Marvin Minsky was a pioneer of artificial intelligence and a professor at Massachusetts Institute of Technology, MIT. He contributed to many aspects of AI, such as neural networks, robotics, computer vision, and learning systems. Minsky defined AI as, quote, "the science of making machines do things that would require intelligence if done by men," end quote. According to this definition, machines do not need to be intelligent in order to do things or achieve results that humans find useful or valuable in many ways. How artificial systems achieve these results is undoubtedly very interesting from an engineer's perspective. But their specific way of operation needn't have anything to do with human intelligence. The term intelligence may have a completely different meaning when applied to machines rather than humans. If we are engineers, we don't care. A different approach to defining AI would be that if humans and machines do the same things, solve the same tasks, and achieve results that we find valuable, there is no reason for us to deny them the attribution of intelligence. In this case, the term intelligence is believed to possess a single meaning, regardless of the underlying causal mechanisms operating at the physical level of a system. As an illustration of this approach, an AI developer tool generating code in a designated programming language is deemed intelligent when the produced code proves to be genuinely effective in addressing a coding challenge. Considering these various viewpoints and approaches, it is beneficial to clarify our precise usage of the term in a particular context to avoid potential miscommunication. Often, intelligence is used as a term of praise, admiration, or recognition applied to a variety of entities. It then relates to our normative expectations concerning some type of socially desirable trait or behavior within the context of a socio-cultural practice, such as investing or creating art. Let's call this sense axiological, i.e., relating to the nature, classification, and sources of value, such as economic, moral, aesthetic, religious, or logical values. As an example, educators instruct their students in the social practice of reading. Typically, we acknowledge a child's proficiency in reading not only when they can recite a sequence of letters, but also when they can effectively summarize or rephrase the content they have just read. On some level of description, state-of-the-art AI, implemented in large language models, perform the same operations. The result can be of great value. Extracting key information from large volumes of text can aid researchers in quickly understanding and synthesizing relevant literature and findings. Used in an axiological sense, the term intelligence bears strongly analogical character. The different senses of the term may resemble each other in certain ways, but not be reducible to any one of them. Reading comprehension is not the same as logical intelligence or economic intelligence, although they often refer to traits and behaviors exhibited by one and the same agent or group of agents. In more technical philosophical terms, it is therefore important to distinguish between the various senses or meanings of a linguistic term, such as intelligence, and its referent, i.e., that which the term refers to in a specific use. Now, sometimes the term intelligence can also have a more narrowly descriptive sense. minimally involving action motivated by preferential choice and guided by some kind of plan or strategy. The question then becomes, are machines capable of acting, following their own choices and plans, or even setting their own values? In general, do they have intentionality? Can they be considered agents in a way similar to the way we consider humans to be agents? Or is this way of talking hopelessly anthropomorphic? Again, it bears emphasis that such questions are first of all philosophical and conceptual in character. From a technological perspective, indulging in their discussion may appear a waste of time and energy. This is perfectly fine. Not everybody need or could be a professional philosopher. But not asking these questions doesn't cause them to go away either. In fact, contemporary scholars in technology are strongly divided among themselves on the conceptual issues raised by our need to define AI. This may partially explain the difficulty in collaboration between AI engineers and philosophers during the research and development process. Engineers may worry that asking too many questions about their work slows them down getting their work done. This is unfortunate, for the earlier in the process of development of a new technology we start thinking about the latter's potential implications for society, the better. As technology becomes more complex, there is an increasing need for interdisciplinary cooperation. As mentioned, one of the most debated issues is whether artificial systems could evolve into independent agents. Traditionally, dating back to the time of the ancient Greek philosopher Aristotle, it has been argued that machines have their so-called principle of movement outside of themselves. Unlike Achilles racing the tortoise in a foot race, automatons are not self-moved. Only living beings are. By extension, automatons do not deliberate on their actions. As Aristotle said, automatons have no power of their own. Nothing lies in their power. On such a position, this remains true even if a robot from the present generation is potentially faster and more powerful than both Achilles and the tortoise combined. We can hear an echo of this view in the claim advanced by contemporary philosophers Floridi and Ciriati, that when Ambrogio, the robotic lawnmower, mows the lawn, the result may be indistinguishable from the result of Alice's work. But this point doesn't make Ambrogio and Alice equals. For these philosophers, quote, "The real point about AI is that we are increasingly decoupling the ability to solve a problem effectively, as regards the final goal, from any need to be intelligent to do so." End quote. On this view, intelligence is human intelligence. Machines need not be intelligent in order to produce astonishing results. But then again, since many of the pioneers of AI were deeply interested in a variety of fields, psychology being one of them, these trailblazing figures would not rest content with such a deflationary view of AI. Combining curiosity about the workings of the human mind with high and often exaggerated hopes concerning imminent scientific and technological advancements in computer science, they were rather convinced that in order to understand a system like the human mind, one has to build such a system. In mid-November 1954, on a Friday afternoon, famous AI pioneer Alan Newell underwent what he described as a conversion experience while he was present at a lecture delivered by Oliver Selfridge, who was developing a pattern recognition system. Henceforth, Newell was firmly convinced that, quote, "intelligent adaptive systems could be built that were far more complex than anything yet done, and that they would be programmed on digital computers," end quote. Now, complexity in a system does not get the latter automatically closer to intelligence, be that animal, human, or divine intelligence. It takes at least one more assumption, shared by Newell and many others beside him, for us to really understand the deeper ambitions pursued by these pioneers. The assumption was, and for many people today still is, that humans are among the most high-powered versions of a computer, whatever else they might also be. Call this assumption of an essential similarity between humans and computers a form of technomorphism, which, like anthropomorphism, continues to cause sharp controversy among philosophers. But here's the rub. The assumption that humans are a type of computer was held to be a scientific fact and thus empirically verifiable. What this assumption fails to notice is that, similar to the mechanical clock invented in the 14th century, the digital computer is at the center of a wholly new way of seeing the world. That the universe as a whole is built like a clock is hardly an empirical fact. Such a view rather denotes a new paradigm and radical shift in human perception. The same goes for the digital computer some 600 years later. Given these different and sometimes incompatible assumptions and pre-understandings, it's not surprising that the endeavor to define AI has been entangled in a thicket of issues that has proven very hard to unravel until this very day. There are those who think they can unravel the thicket mathematically, so to speak. One prominent figure in this context is the mathematician Alan Turing, who is best known for proposing the test named after him. In case you should not know how the Turing test works, let's ask ChatGPT about it. Now that you've just observed an occurrence of what is commonly referred to as machine hallucination, resulting in factually incorrect information caused by a typo in the original prompt, let's look at the real thing. Typically, the Turing test involved a human judge engaging in natural language conversations with both a machine and a human without knowing which is which. If the judge cannot reliably distinguish between them, the machine is said to have passed the Turing test and thus possess intelligence. As you can probably guess at this point, despite its wide influence, the Turing test hasn't put an end to the discussions about how to define AI. Instead, what is about to end here and now is the present episode of this video series. Thanks for watching and see you next time.